So here's a set of instructions on how to draw Lewis structures for molecular compounds and polyatomic ions. And this sort of is like the instructions for balancing chemical equations. There's not one set of directions that I can give you that's going to work every single time. So it's more like guidelines. And there's more than one way to write a good Lewis structure, to come at the right Lewis structure. But this is what the book uses, and I think it's pretty good. So we're going to go with it. So the first step is to get the correct skeletal structure. What that means is you have to figure out how are the atoms connected to each other. And that can be tricky when you're starting out. One thing that's really important is that hydrogen atoms are always terminal, meaning they're always on the outside at the edges, because hydrogen can only form one bond, so it can't be in the middle of anything. It's got to be hanging on the outside. Another guideline is to put the more electronegative atoms in terminal positions. So you're not sure which to put in the middle and which to put around the outside. Put the more electronegative, the one that's closer to fluorine, on the outside. Molecules also tend to be symmetrical. Not always, but often they're symmetrical. And so if you're not sure, going with symmetry is a good place to start. The next thing we need to do is figure out how many dots are we going to show in this structure. And that's going to involve adding up the valence electrons for each atom. So you look, what group on the periodic table is it in? That's how many valence electrons. Do I have 2 carbons? They each have 4, so that's going to be 8. So you just add them up. If you have an ion, then you have to adjust the number of electrons based on the charge. Positive charge means you subtract electrons. Negative charge means you add electrons. Then you just start handing out electrons. So there has to be a single bond, at least, between all of the atoms in this molecule, or it's not going to hold together, right? So you put single bonds in, and then you start distributing lone pairs of electrons, and you try to give everyone an octet, except for hydrogen, just needs 2. Now, sometimes that works out great. Other times you run out of dots. And if that happens, if you've got atoms without an octet, then you're going to need to do some more sharing. Use double or triple bonds. So those are the guidelines. Let's practice. So let's do carbon monoxide. So CO, how to put these together isn't much of an issue because the carbon is next to the oxygen. So there's carbon and here's oxygen. And the next thing is to figure out how many electrons, how many valence electrons. Carbon has 4 and oxygen has 6. 4 plus 6 is 10. Okay, I'm going to put 10 dots here. Well, I need a single bond, right? So I have to put a single bond here, and I'm going to use dots here for a while just to help you remember. That's 2 electrons, right? So I got 2 electrons in the bond, and I'm going to keep counting. You need to be able to count by 2. I don't think that's going to be a problem for anybody. So we go 2, 4, 6, 8, 10. I'm just handing out lone pairs until I get to this number, and then I have to stop. And I look at what I've got, and I ask myself, is everybody happy? Does everybody have an octet? No. Carbon here has got 2, 4, 6. Oxygen 2, 4, 6. I like to just sort of spread them out equally, but it doesn't exactly matter how you do that. Nobody's happy. There's not enough electrons for everyone to have an octet. That means we need to share some more. So what we're going to do is we're going to take one of these lone pairs. I don't care which one. We're going to take one of these lone pairs and make it a bonding pair. I'll just pick that one. And so we're going to put that up here and make that a bond now. I still have the same number of valence electrons, but I'm just arranging them differently. So now this carbon has 2, 4, 6, 8. The carbon's happy. Oxygen has 2, 4, 6, not so much. I'm short electrons. I need to make a triple bond. Now, I don't want to take this lone pair because this oxygen is the one that needs more electrons. What I'm going to do is I'm going to take a lone pair from the oxygen that has from the carbon because it has an octet. This one's happy. It's in a good place. It's like, hey, I'm all good. You're not happy? I'll share with you. So we'll take one of these lone pairs and share it. I'll just maybe choose this one up here. And we'll put that over here as a bond. I have the same number of dots. I still have 10 dots. Now the carbon still has an octet, 2, 4, 6, 8, and the oxygen has an octet, 2, 4, 6, 8. We made everybody happy. I like Lewis structures because you can make everybody happy. It doesn't happen in real life. Now that looks kind of ugly, right? So we might want to write that neater. And so we've got carbon and oxygen, and we have a triple bond. And then each of these has a lone pair. So I like to put those on the outside. Lewis structure for carbon monoxide. Any questions? Okay, let's do H2CO. So we got 2 hydrogens and a carbon and an oxygen. Well, the hydrogens are going to have to be on the outside. So let's put carbon here and oxygen there, and we have to figure out where to put the hydrogens. Let's try putting one over here and one over here. I know that's wrong, but we'll see what happens. So there would be a bond, a single bond between these to connect them. We need to know how many total valence electrons we have. We have 2 hydrogens. They each have how many? 1. And we've got carbon has how many? 4. And oxygen has 6. So this one has 12. We have 12 dots. I already used up 2, 4, 6 of them. 8, 10, 12. I don't have enough. What do I do? Multiple bond. So can I make a multiple bond between oxygen and hydrogen? No. How about hydrogen and carbon? No. So it's going to have to be between the carbon and the oxygen. And the carbon here has an octet, and so I'm going to take that pair of electrons and share with the oxygen. So I take those guys, put them over here. Now what do I have? I have 2, 4, 6, 8, 2, 4, 6, 8. The oxygen's happy, the carbon's happy, both the hydrogens are happy. So at this point, that is a valid Lewis structure. We're going to learn in a minute, though, well, maybe 5-10 minutes, that that's not actually how that one's going to go. Do you remember I told you that you can kind of predict how many bonds something's going to form by looking at the unpaired electrons that it has in its atom? So that's oxygen. Oxygen has 6 valence electrons. Oxygen's probably going to want 2 bonds. Carbon has 4 valence electrons, 1, 2, 3, 4. Carbon usually likes 4 bonds. So, do we have that going on here? No. Oxygen has 3 bonds, carbon has 3 bonds. That's actually not the correct Lewis structure. Well, how else could we do that? So the carbon and the oxygen have to be bonded to each other. And we're going to need a double bond, and the double bond can only be between the carbon and the oxygen, so it's got to be there. And then we've got hydrogens. Now, what I've got going on here, how many bonds does oxygen have? It's got 2, so that's probably good. And the carbon would like to have how many bonds? 4. And I've got 2 hydrogens I need to stick on there. If I stick a hydrogen here and another hydrogen on the carbon, now the carbon has 4 bonds. So what I'm doing is I'm adjusting this, and we'll learn in a minute that you can do it a different way using formal charges. But let's count how many electrons I've got in there right now. I've got 2, 4, 6, 8. So I need to put in some more. 10, 12. Does everybody have an octet? Yes, they do. This is a better Lewis structure. This one's better. Any questions? Polyatomic ion. Hypochlorite. Remember that guy? Well, this is simple again. We've only got 2 atoms, so we don't have to worry about how they're connected. So there's chlorine, there's oxygen. How many valence electrons does chlorine have? Somebody say it loud. 7. How many does oxygen have? 6. I know that didn't go very well, did it? What does the -1 mean? Do I add an electron or take one away? I add because I'm adding a negative, so I need to add 1 electron. So +1. So I believe that's 14. So I need a bond there, and that's 2 electrons. And so I've got 2, 4, 6, 8, 10, 12, 14. Cool. I had enough electrons to give everybody an octet without resorting to multiple bonds. We can see the octet easily because there's a pair above and below, to the left and to the right. This is a bonding pair, but it's still a pair. 4 sides, 4 pairs, 8 electrons. The other thing that we need to do here, because this is an ion, is we need to put brackets around it and indicate the charge. Otherwise, somebody looking at that is going to say, you had too many electrons in there. Chlorine and oxygen together only have 13 electrons, and you drew 14. It's got a -1 charge. Now, on mastering chemistry, you would think that they could figure this out, but they haven't figured it out yet. The program can't do the brackets. So you still have to indicate the charge, but you can't do brackets on mastering chemistry. So just watch out for that. Don't text me and say, how can I put the brackets on my polyatomic ion? You can't. It just doesn't do that.